Hey everybody, in today's video I'm going to talk about net present value and how to calculate it in Excel and how to calculate the internal rate of return. So with net present value, generally the scenario is that you're investing an upfront amount today and then you're expecting savings from that or some sort of cost benefit in the future. So you want to figure out if it's a project that's worth taking on. And you could also make investments, additional investments along the way. It doesn't have to be all up front. Obviously, every scenario is different, but in this case, I'll just use a simple example where let's say we invest $1,000 in the first year. And then let's say in year one, you're saving only $50. And then it becomes $100 in year two, $250 in year three, and then in year four, $300, and then in year five, $600. So if I add all this up, that's $1,300 that I'm saving from this $1,000 investment. But the problem is we have to factor in the time value of money because obviously we can't just look at this in just the raw numbers because sure, we're going to get $1,300 back, but is that really the best use of this $1,000? It always comes back to whether you're making the most of your money. And this is where it's important to also consider the discount rate. And the discount rate is often the most challenging part of these questions, especially if you're doing them for an exam or whatever the case may be, or an analysis, because you have to figure out what discount rate you're going to use. And typically, you want to find something that's at least as good as what you'd be getting with a risk-free investment. Like let's say putting the money into a low-risk treasury bill, or let's say putting into a savings account, for example. Let's say we use the percentage of 5%, right? Saying that, okay, that given the interest rates are as high as they are right now, you can make a 5% return pretty easily on a lot of investments. So let's say, that's the discount rate you're going to use. You're going to say that over the next 5 years, you could expect to make 5% every year. Or maybe you want to use 4%, 3%, whatever the case may be. Figuring out that discount rate can be oftentimes the most challenging part of this process because what you use it for that discount rate is going to impact heavily on what your net present value calculation is going to show, because ultimately all these values need to be discounted back to the present value, and the present value calculation incorporates this percentage. So if you put in 10% versus 2%, that's going to have a very big impact on your net present value calculation, which is going to tell you whether this is a good investment or a bad investment. So this is not something that you should not spend too little time on, because it's an important part of the process, probably the most important, because in addition to knowing how much you're saving, you need to know what the value of all that is right now. So I'll have a row here for the present value. So in year zero, obviously there's no discounting that needs to take place. I'm just taking that straight $1,000 that's coming out of the bank account today. So that's just a negative value today. And so I'll indicate that with a negative. Now the cost savings values, these are positive. These are good values. These are values that are going to help prove my case that this is a worthwhile project. So in this case, I'm going to leave them positive. But what I need to do is take this $50 in this case, and then multiply it by a factor of 1 plus this discount rate, and I'm going to raise this to a power of -1. And rather than entering -1, I'm going to code it in here so that way it automatically updates as I move this formula, because it's going to be -1 here, -2, -3, -4, -5, because that's how many periods I have to move it back. So that $50 in year one is worth 47 roughly $62 if I pull it into today's dollars. So what I need to do is I need to freeze this value, this discount rate, because this I don't want to move. These other values will be fine. So now I'll move this formula over here, And now we've got, this $100 pulled back 2 years at that 5% rate. In today's dollars is worth $90.77. So I spread this across, and I've got all my values. So you can see that $600 in year 5 is only worth $470 today using that 5% discount rate. Now, if I were to change this discount rate to only 3%, then that value shoots up to 517 now, because now I'm not losing as much along the way. It's only going by 3%. So I'm only discounting by 3% each year. So the interest rate or the discount rate isn't as high. But I'll change it back to 5% just for the sake of making this a bit closer in values. So now, if I were to sum all these values up using the auto sum here, I can see that the value is a positive $71.21. So that tells me it is a positive net present value. And so that these positives outweigh this $1,000 even when they're brought to today's values. So that tells me that the project is worth it based on this 5% discount rate. Again, if I change this to 3%, it's even a better option, because now that present value is 155, because again, there's less discounting going on. But if I want a 7% discount rate, now I'm in the negative. Right, so now you can see the difference in percentages can make a big impact on whether you say this project should go ahead or whether it shouldn't. So if I go back to 5%, it's still okay. Now you can also do this just using the actual NPV formula in Excel. So this is what I'm going to say is my calculated value. And now let's do the NPV function. So for the NPV function, type in NPV. And now, so we've got our rate, which is the 5%. And then what we're going to do is take in all these future values, starting with year 1, 2, 3, 4, and 5. And then I'm going to add my initial investment amount, this minus $1,000. And I get to the same value, 71.21. So as you can see, whether you're doing it manually through these steps, and I just wanted to prove it out, you're going to get to the same result, because this net present value formula is going to do the same thing. It's going to pull in these values, and using that discount rate in C2, it's going to adjust them back to today's value, factor in that initial investment to tell you, whether this project is a go or not, whether it's positive or negative. Now, the inevitable question you might have with this is, at what percentage does this break even happen, where the investment today is worth the same as all of those future outflows discounted back in today? Because obviously you don't want to be playing around with this rate nonstop to say, okay, how does it get to zero? What's that magic rate? You don't want to have your initial discount rate that you're going to use. You can also use the IRR function, the internal rate of return, and this will calculate that break even percentage for you. So if I type in IRR, and then what I can do is just pull in these values. And actually, I'll put them all in the same line here. Put 1,000 here as well. And use, actually, that should be a negative 1,000. So if I use the IRR function, and then I can pull in all those values, it's going to tell me my rate is 6.86%. So if I enter that here, 6.86%. You can see we're really close. Obviously, it depends on the decimal point. So if I copy this exactly, copy, paste values, now I've got exactly 0, because obviously there's a lot more decimal places in here. But basically, you can see that at this rate now, that's basically the break-even point where the savings are the same value as, or the savings are the same value as the investment. They're basically a wash. So that tells you, if you go above that amount, then you're in the negative. Then the project is too costly. It doesn't generate enough savings. The higher you are from that, the worse it is. And on the flip side, if you're below this rate, let's say 6.5, you're already in positive territory. So the lower this discount rate is, the more likely you are to go ahead with the project. So let's say 4%, even bigger. So the smaller this discount rate, the more likely it is that you'll go ahead with the project, because that'll make the net present value higher and show to be more beneficial, more profitable. So as you can see, like I said initially, there's a lot of importance to this discount rate, because that can instantly make a big difference on this NPV calculation to say whether the project should be a go or not, because that's going to determine what the present value of these future savings are going to be. So this is a really important piece that you want to focus on, that discount rate, to make sure that you've got something that's justifiable. Because really, if you can say you can make 4 or 5% on an annual basis using pretty low risk option like investing in government bonds or whatever the case may be, then why would you want to go ahead with this project that presumably takes on more risk, and maybe it only yields 5.2%, right? So that's the sort of thing that you want to consider in your discount rate. You may not necessarily want to use 5% if 5% is what you can get with taking on no risk or minimal risk. If 5% is the no risk discount rate, then you'd probably want to go to maybe 6% or 7% to say, okay, we're taking on some risk, so it should be compensated for that by using and get a better rate of return on our investment. You don't want to just simply match the low risk or no risk option. You want to do something better than that, because you are taking presumably some risk with a project or an investment that's going to take years in the future to pay off. So that's in a nutshell how you can do a net present value calculation in Excel and calculate IRR. The key thing is to remember, you just want to map out your savings correctly and in the right periods, factor in the current investment, and very important is the discount rate that you're going to use, because as you can see, it can make a big difference on whether your NPV value is positive or negative and whether you should go through with it. And the IRR function is really just taking a sum of, or taking all those values, and it's automatically going to adjust them assuming they're in the right corresponding period and do that calculation for you. And IRR is really just your sort of break-even point to say, okay, this is the percentage. Anything higher is a no-go. Anything lower than that is going to be good. So hope you found this video useful, and thanks for watching.